we've got a report that's been prepared by our Australian panel convener, Mr. Yi Li, but unfortunately he can't make it today and he does send his apologies. So on his behalf, we have Dr. Winston Yan, who is the Australian panel member and who is also the incoming Australian panel convener. So I'd like to welcome Dr. Winston Yan.
Okay, thank you, Angela. Yes, Angela mentioned we have a little bit transitioning of convenership in D1, so I have the privilege to be the next convener for the next period. So, today I'm going to give you an update of the activities of D1 and D1. Which button should I be pressing? Yeah, so D1 is all about materials in the high voltage system and also the testing techniques. So we have several principal areas of interest covering insulation materials, basically gas, insulating gas, and liquid, which is oil, mostly oil, solid materials, including polymers and pressboard, paper, used in transformers and other equipment, and also another big area is high voltage and high current testing techniques. So the work is focusing on developing new materials and also the test method to validate, to evaluate those materials, and study of emerging test and diagnostic techniques for high voltage AC and DC systems. I think it's also develop material and diagnostic tools for the new materials. For example, the new gases, replacement gases for SF6, and also covering the test for more traditional materials like insulation oil and all the things we already been using. So the structure of the D1 international organization is we have the chair is Simon from the UK and also Gordon. We have about 30 members, regular members. The areas are divided into 4 advisory groups covering the 4 main areas I was just talking about in the last slide: liquid, solid, and gas. Also one in the high voltage and high current testing techniques. So under the 4 AGs, we have about 30 different working groups, and because we have, when you're talking about high voltage testing techniques, you normally test some equipment, so there's a lot of crossover with different other different technical committees. So there's quite a few joint working groups under this 4 areas, and so we have. I think we have 3. So this is only one of them. But by the time of now, I checked yesterday. So 3 of the new working group have been approved in 2025. This one is about design of transformers for VFTO, very fast transient over voltages. It's a joint working group. It's looking into the how to design a transformer which is suitable for to be used in GIS, where a lot of faster transient over voltages happens compared to the more traditional transformers. So there are standards. The transformer standards, they are testing they test the transformers with a bit slower voltages, but because of this VFTO, so more testing techniques have to be developed. This is covered in this work committee. The D183 and D1A284, they are already approved. I think I checked yesterday. The first one is about how to use optical method to test the to monitor the partial discharge activities, especially in GIS. So the advantage of using optical is because it's better, is less prone to magnetic interferences, and they can be mounted in the GIS to give you real-time monitoring, and it's also very sensitive to PD activities. 84 covers silver corrosion within the transformer, so silver is not very much looked into in the areas of corrosion. So the silver is used in the contacts, and they can be reacting with the sulfur compounds and forming some other elements, forming other materials, which will be reducing the lifetime of transformer. So this is what this one is looking into. We also have a few proposals being finalized, including the gas decomposition and material compatibility for the new replacement gases. Also, there's another one about evaluating the tightness of gas tightening systems in GIS. This is under development, these proposals. 4 technical brochures has been published in 2025. The first one is about the interaction of cable and its accessory materials in the high voltage applications. As you know, the interface between the cable and accessories are critical, and they could be the cause of a lot of failures in the system. So this is all about that. The 976 is about mechanical properties of insulation materials, including paper, pressboard, laminated wood, and aramid-based components. Looking into the mechanical properties, for example, when you subject to high current event, there's going to be mechanical forces created in the transformer, and this one looks into that area. And 957 is about dielectric testing of gas-insulated cable, and 952 is about the hydrophobicity the method of evaluating hydrophobicity property of polymer insulation materials. There's a so-called dynamic drop test being created, and it's used on silicon rubber surfaces. And a round robin test has been going on, and to see how repeatable this test result is on polymer materials. These are just screenshots from the SIGRI website about the brochures. In the last year, we had an annual meeting, which happened on in the A2D1 colloquium in Seoul. The next D1 meeting will be in Paris, along with the Paris session, and in 2027, it's going to be in Germany, tentatively in Germany. With at the same time of the symposium in Heidelberg with, I think it's with A2 together. Next year also we're going to have the Paris session. We have involvement. The activities in Paris session will be, we'll have a poster session of D1 and workshop about driving T&D substations and equipment towards net zero emissions. There's going to be a B1 tutorial on cable, which will include the work of the joint working group of B1, B3, D1, and it will be about dielectric testing of HVDC gas insulated system cables, sealing ends. The second day, we'll have the D1 group discussion meeting, and then the study committee meeting, and another D1 tutorial will be happening in the following days. Preferential subjects for the Paris session. We have 3 subjects. The first one is about testing, monitoring, and diagnostics. Then another one is about the materials for electrotechnical purposes and modeling. This is more about traditional insulation materials. And there's another subject is for the newer materials for reducing environmental footprint and like for energy storage, batteries, and also there's a topic about hydrogen. Locally, we had a D1 annual meeting along with the SIGRI Australian Conference. We had 15 members at that time, and we gave some update of what was happening locally. For example, I'm from NMI, by the way. We had did some tests in faster transient measurement in the substation, which is caused by the operation of disconnectors. So we had some. This is a collaboration with Electronet. So they found some of the CTs were damaged by the activities of disconnected opening and closing, which creates a lot of a pulse train of high voltage transients. So we did some on-site measurement and we did some simulation about it, and so we reckon that some more work have to be done to be able to more accurately measure such voltages, so that you can design and test your transformer before putting it next to the disconnectors. And Omicron had a presentation about cybersecurity, and there's some method of how to test the switchgear of taking advantage of digital twins presented by Mega. So also, some other interesting topics we can talk about after this. At the moment, we have about 20 memberships we have a good coverage of utilities, equipment manufacturers, and universities, test facilities. Participation. We're also actively participating in a lot of working groups internationally. So these 3, we have the Australian D1 member are the conveners of these 3 working groups internationally. So if you wish to have some more discussion or interested in joining any of the working group, please let me know. And I'll try to as I said, I'm going to be the next convener of this group for the next period. So I'm trying to fit the shoes of Yi, who I really appreciate his leadership in the past few years, and trying to fit into his shoes as best as I can. Okay, thank you very much.